Assalamualaikum and good day class. So let's continue with 10.2 superposition of waves. Okay, so the learning outcome 10.2b, use the standing wave equation. So it's very important for you to remember that this is the standing wave equation. So I'm going to put here hashtag wajib hafal. So this is the general equation for standing wave. So what is a standing wave? Basically, standing wave is a result of superposition of the two waves. So this will be the equations. Okay. So the two harmonic waves are represented by the equations below, where y1 and y2 and x are in centimeters and t is in seconds. Write the expression for the new wave when both waves are superimposed. So what you need to do first is you determine. So the amplitude is, so the amplitude here is, okay, first let's just write down. So for the superposition is y1 plus y2. Okay, so the general equation is y equals to a cos kx sine omega t. So for this case, what you need to remember is the amplitude is basically to small letter a, but the small letter a is the amplitude of the corresponding waves. Okay, so it is the amplitude of the wave. So let's put this one as a capital letter. Okay, to note that this is the superimposed wave. Okay, so this is the standing wave. So what we can do here is just write the general formula a cos kx sine omega t. So the small letter a is 5. K is, what is the value of k? So k is 2 pi, and the omega is pi. Okay, so that will be 2 pi cos 2 pi sine omega is pi t. So expand that, that will be 10 cos 2 pi. Sorry, I forgot to put my x here. Okay, so cos 2 pi x sine pi t. So that is how you do question part A. So for part B, determine the wavelength and frequency of the stationary waves. Okay, so they want you to find the wavelength and the frequency of the stationary wave. This one you can use the formula that we know before. So let's start with the wavelength. So to find wavelength, so we know that k is 2 pi over lambda, and let's make lambda, which is the wavelength, as a subject. So that would be 2 pi over lambda, and 2 pi over k, and our k is, what is our k? Our k is basically 2 pi. Okay, so 2 pi divided by 2 pi. So your lambda is, answer should be, your lambda is 1, and the unit is in cm. Okay, for the next part, you want to find the frequency. So to find the relationship of frequency, we know that we need to use omega. So omega equals to 2 pi f. Make f as a subject, you will get omega divided by 2 pi. And our omega is pi. So pi divided by 2 pi. So your answer for the frequency would be 0.5 hertz. So that is how you do for part B. So now let's try to do question number 2. So for question number 2, we have a stationary wave is represented by the following expression, where y and x are in centimeters and t is in seconds. Determine the three smallest value of x that correspond to the nodes and antinodes. Okay. Okay, first you need to remember for the formula of node, the formula of node would be x equals to n over 4 lambda, where n starts with 1 3, 5, okay. So we are going to substitute, but first we need the value of lambda. So lambda we can obtain from the equation here. So from this one, we know that our k is 0.55 and our omega is 5 pi. Okay, remember it is in centimeters. So to find lambda, we need to use k equals to 2 pi over lambda, and lambda is equals to 2 pi over k, where your k is 0.5 pi. So basically, your lambda, your for value of lambda is equals to 4 and the unit is in cm. Okay, so what you need to do is you just substitute n, the integer, into the formula and lambda, which is 4 cm. So x1 equals to 1 over 4. So for x1, that would be 1 cm. Okay, for x3, okay, 3 would be 3 over 4, sorry, 3 over 4, and the lambda is 4, so the unit, the answer will be 3 cm, and x5, so when we are going to substitute 5 over 4, so this is 4, so the answer would be 5 cm. Okay, next for the antinote. Okay, for the antinote, the formula would be x equals to m over 2 bracket lambda. But for this case, your m gonna start with 0, 1, 2, 3, and so on. This whole three, so on. Okay, so they just ask you the three smallest values. So we are going to substitute x0 equals to 0 over 2 lambda. So you get here. Okay, should we include the 0 for the antinote? Okay, it is stated that x must be bigger than 0, okay? So x must be bigger than 0. So we are not going to substitute x0. So we are going to start with m equals to 1, sorry. So m equals to 1. Well, so we substitute n equals to 1. So half, this is 4. So you will get x equals to x1 is 2 cm. Okay, for x2, this is 3. Okay, for x2 is 2 over 2, 4. So you put here 4 cm, which is your x2, and for x3 is equals 2. X3 is 3 over 2, 4. So you'll get 6 cm. Okay, so that is how you do part A. So for part B, so they ask you the amplitude of the particle at x equals to 0.5 cm, x equals to 1.1 cm, and x equals to 2.2 cm. What you need to know is to find amplitude, we are going to look at this part of the equation. So A equals to cos x only. Okay, to find the amplitude, we are going to look at this part of the equation. So for our equation, which is 15 cos 0.55 x. Okay, so we are going to use only this part of the equation, and we are going to substitute when. So when x equals to 0.5. So when x equals to 0.5 cm, the amplitude would be, what you do, you just substitute 0.5 cm cos 0.55. So this one would be 0.5. Okay, close the bigger bracket. So you will get 10.6 and the unit is in cm. So the next part would be when x equals to 1.1 cm. Okay, so when x equals to 1.1 cm, the amplitude would be 15 cos 0.55 close bracket 1.1 cm. So this is the bigger bracket. Okay, so this is actually cos. So press your calculator. So you would get negative 2.35 cm. And for the last part, for x equals to 2.2, so when x equals to 2.2 cm, so the amplitude would be 15 cos 0. Cos, 0.55 multiply with 2.2, close your bracket. So that would be, press your calculator, you should get negative 14.3 cm. Okay, so that is how you do question number 2B. Okay, next for question number 3. So I want you to try to do it on your own and post your answer in the Google Classroom. So thank you very much, class. I'll see you guys in the next video. Assalamualaikum warahmatullahi ta'ala wabarakatuh.